Hi viewers, welcome to LMR Solution. Today we are going to see about designing of a PI controller for speed control of brushless DC motor. So this is the brushless DC motor simulation model. So this model consists of controlled voltage source and then voltage source inverter and BLDC motor, and here we are measuring the output of Hall sensor. So based upon Hall sensor, we are going to convert the Hall sensor output to a back EMF. So by using this decoding concept, decoder. Okay. So conversion of Hall sensor output into back EMF of the BLDC motor. So next we need to convert that back EMF into getting signal for voltage source inverter. So based upon back EMF, we have to convert the getting signal. So by using this control logic, so just you have to compare the back EMF with 0, greater than 0, less than 0. So that going to be generate the pulse for 6 switches of the voltage source inverter. Okay, and then we need to control the speed of the BLDC motor. So for that we need to use controller, right? Normally we are going to use PA controller. So that in order to design the PA controller, so first we need to find the transfer function of this BLDC motor system. Okay, so here you can see that the input for the BLDC motor will be voltage, and then here we are going to control the speed of the BLDC motor. So we need to measure the speed. Okay, so input will be voltage, the output will be speed. Okay, just you have to collect the data first. So for that I am going to provide the input equal to 400 volt. That means this motor will be operated at 400 volt, right, rating. And then here I am going to collect the output data. Okay, and also here I am going to change the load torque from 0 to 3 Newton meter at 0.1 second. Okay, for that settings I am going to collect the data now. So for that just I am going to simulate the model. So after simulating this model, so here you can see that, right, you will see the input data, output data. Okay, in the workspace. So by using this input and output data, we are going to develop the transfer function model for our system. So for that I am going to use system identification toolbox. Just you have to click this one. So after clicking this one, go to this import data and click time domain data, and here you have to provide that input and the output variable, right, that means from this workspace. So and then you have to provide the starting time is equal to 0 and sample time, right, sample time should be taken from this power GUI, right. So here you can see the sample time is 5 e power minus 6. Okay, just you got to take the 5 e power minus 6 and then click import. So after that you can see the data here. So this is the data taken from that input output, right. So next you go to click estimate and then click transfer function model. So here you have to provide number of poles equal to 1, number of zeros equal to 1 and click estimate. Okay, and click estimate. So after estimate, right, here you can see that, so it will be estimate the transfer function model and click close and click this close button. So here you can see that, so this is a transfer function output, right. So now you right click this one, so you will see the transfer function for the particular input and output. Okay, so this is the input output of the that means transfer function model for that BLDC motor control. Okay, so now we are going to design the PA controller. So here I am going to make close to control, and then here I am going to use some. Okay, and then here I am going to use PID controller. So here we are going to use only PA controller. Just to change PA controller, and then you take the feedback from the BLDC motor, and then just use constant. So constant here I'm going to maintain it equal to 3000 rpm, and here you going to change plus minus, and then here you can change this output, that means connect this output of PI controller to the controlled voltage source. So now you have to provide the value for PI controller, so that can be provided based upon the transfer function. Okay, so here it is a transfer function, so just you have to provide the value for kp equal to 1, that means coefficient of this s. So just you see the numerator, right? So coefficient of the s will be value for kp, and this constant, right, known as a value for ki, right? Just you go to change here 318.4. okay, and then click apply and okay. So now you can test the system, right? I'm going to simulate the model. So now you can see that, so it has some overshoot. Okay, and then after some time, now after point not 2 seconds, right, the speed is set at 3000 rpm, right? That means the controller track the speed, reference speed command, and after 0.1 second, right, so there will be changes in the load torque from 0 to 3 newton meter. So after that, because of increasing load torque, right, so it go for undershoot, and then it's come to 300 rpm, right? So the controller will be effectively control the speed of the BLDC motor. Okay, so next I'm going to check the model with the change in speed command, right? So I'm going to change the speed command from 3000 to 1500 rpm after 0.1 second. Okay, and I'm going to check the response of the speed. Now also you can see that, right, after reference speed command change, right, it changed from 3000 to 1500 rpm, right? So it will take around 0.03 the seconds to settle the final value. Okay, so this is a designing of PID controller, PA controller for a speed controller BLDC motor. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.